So in part A, they're asking you to use a left Riemann sum with 3 subintervals. Okay, so I would go up to the top at the chart up there, and let's break these off. 1, 2, 3. Okay, so if you look at the first subinterval from 0 to 2, you see the width of that subinterval is 2. And then the height is going to be, now we're using a left Riemann sum, so we'll use this value on the left side of that interval. So that's going to be 50.3. Okay, plus, then we're going to go to the next interval. So we're looking at between 2 and 5. So that's a distance of 3. And then the left side is the 2. So we'll use 14.4 for the height. So that's going to be 3 times 14.4 plus, and then lastly, the last interval is going to be from 5 to 10. So that's a distance of 5. And if we look for the height of this rectangle, we use the left Riemann sum, which would be 5, and its corresponding height will be 6.5. So then we're going to have 5 times 6.5. Now remember, this is a calculator question. Okay, it says it right up here, graphing calculator is required. So then you just plug this into your calculator, and you're going to get 176.3. Just don't forget to write this is volume, so it is feet cubed. It does say to indicate your units of measure. So part B is asking if the approximation that we got in part A, which was the 176.3 feet cubed, is an underestimate or an overestimate. So usually what I do in that case is I look at the chart that's up here at the top, and I'm just basically going to plot these points. So I'm going to plot 0, 50.3, and it's just a rough estimate, guys, so don't go crazy with it, and then so on. So 0, 50.3, actually let's put this in a different color so that we can see a little bit better, is roughly somewhere around there, right? And then the next one would be 2, 14 point something or other. Okay, the next one is 5 and 6.5, which is roughly around here, and the last one is 10 and 2.9. So basically you just want to kind of get the general idea that this thing is decreasing. Okay, now we did left Riemann sums. So remember, left Riemann sum means that if I'm looking at my first interval, which is between 0 and 2, so that's between 0 and 2 here, I go to the left part of that interval, which is 0, go up to its height, and then I'm going to draw the rectangle. So then my rectangle is going to go like that. Okay, sorry, it's not the best picture in the world, but you get the general idea. 2 to 5, 2 is on the left-hand side, so I start at 2. I go up to where it hits the graph, go over to the end of that interval, and down. And the same thing with 5 through 10. So I go up to where 5 hits the graph, it's right here, go over to the end of the interval, and down. Now you can see that my rectangles, which are in blue, look at them. All this space is above the curve, so that's definitely an overestimate. So then you would just say that it's an over approximation, okay, or an overestimate. And the reason would be because A of t, which is my graph that I have in red there, is decreasing. Decreasing from 0 to 10, which then would make my left Riemann sums over approximations. You can also, if you wanted to, you could say it's an overestimate, and you can actually just show this graph and then just show that your Riemann sums, right, cover area that's clearly above the curve. That's also absolutely fine. Okay? So part C, it says the area in square feet of the horizontal cross-section at height h, so remember this height is going to vary, is modeled by the function f given by. So here is the area of a horizontal cross-section. We don't know, they're talking about a tank, but we don't know what the tank is in a shape of. We don't know if it's a cylinder, we don't know if it's a pyramid, I mean, we have no idea. So what they're telling us though is whatever the shape is, that cross-section shape is, this is the area of that cross-section shape, okay? And based on that, they want us to find the volume of the tank. Well, let's just think in very, very general terms. So remember, if we want to find volume, isn't that the integral of the area? Right? And don't we have the area right here of that cross section? So then to find the volume then, we would essentially just take our f of h dh, and we're going to integrate it. Now remember, the height is constantly changing, but if you go back and you look at the chart that you were given at the top of the page, the height goes from 0 to 10. So then all you have to do is just put this right here in your calculator. And again, just remember, that's your f of h. So I would put your f of h in your y1, and then do math 9, plug everything in, and see what you get. All right, you should end up with 101.3253, and that will be feet cubed because it's volume. Okay, don't forget, you always want your units of measure. So there's our final answer right there, okay? It says water is pumped into the tank. Now here's our first bit of information that they give you. They say when the height of the water is 5 feet, the height is increasing at a rate of 0.26 feet per minute. So let's just write that down. So when h is 5, then that would be dh dt, right? And it's increasing, so that'll be positive, is 0.26. Let's keep reading. So it says using the model from part C. So in other words, we're probably going to have something to do with f of h. Find the rate at which the volume is changing. Isn't that dv dt? With respect to time, here we go. When the height is 5 feet. All right, so let's look at the next thing they're asking you to do. So they're saying find the rate at which the volume is changing with respect to time. So that's what we're looking for. But at that time, we know that the height will be 5. Notice that both things that they just gave you here, height is 5, height is 5. Okay? All right, so let's figure out what we have to do here. So it says find the rate at which the volume is changing. Well, shouldn't we have a volume formula then first? And don't we have that volume formula from part C? So we have, and let me just box this off so we keep that as separate. So we have volume is equal, remember we did the integral of the area, and the integral of the area was f of h, generally speaking, dh, okay? So if I want dv dt, wouldn't I take the derivative of that? So let me just show you. So I would take the derivative of this, and I would take the derivative of that, right? All right, so that's going to give me, dv dt equals, and then over here, remember a derivative and an integral cancel each other out. So that's going to give me just f of h, and that would be with respect to h, so we write dh dt. Okay, now this whole scenario, and let me just, actually, let me not do it that way. This whole scenario here is at time 5, don't you agree? Time 5, time 5. So I want dv dt at time 5, f of h at time 5, and dh dt at time 5. Okay, all right, so here, let's just keep going and see if this makes sense. So then I'm looking for dv/dt, right? dv/dt. So this is going to be f of 5, right? And then I also want dh dt. And I'm just going to write it like this, at time 5. Okay, well, f of 5, knowing what f of h is from part C, right? You should still have that in your y1. All you need to do is evaluate that at 5. So if you go to your home screen, remember you hit vars, yvars, enter, enter, and a y1 will pop up. Open a set of parentheses, put in a 5, close it. So just like that. All right, so then we're going to write dv/dt equals, now we know that f of 5 is 6.5, right? 6.516999, so on and so on. Okay, so 6.5169. Then dh dt at time 5, if you look over here, that's 0.26. So we're going to multiply that by 0.26, throw that into your calculator, and you will get dv/dt equals 1.6944. Now remember that this is a rate, so, and it's a rate of volume, so always in this case feet cubed per, and the time unit was minutes. Sorry, I'm trying to stick it in there. Okay. All right, so now if this was your AP, I would not just leave it like that. I would give a written explanation. So something like, when H is 5, the volume of the water is changing at a rate of, and then 1.6944 feet cubed per minute. Okay, rewind that if you need to. All right, it's really important to read this question very carefully so that you have a full understanding of what's going on, and you might have to read it more than once or twice. The first thing I want to point out is it says when the grocery store opens, it has 50 pounds of bananas. That's time 0. So at time 0, you have 50 pounds of bananas. Okay? All right, the next thing I want you to read, it says customers remove bananas at a rate modeled by. So this, you need to understand, first of all, it's a rate, okay? And it's a rate of removal. Now keep reading. Where f of t is measured in pounds per hour and t is the number of hours after the store is opened. All right, here we go. After the store has been open for 3 hours. So for example, if the store opens at 8 a.m., that would be at 11 a.m. Okay, but we'll leave that for now, but I'm going to keep it underlined. Store employees add bananas to the display at a rate modeled by. So this is also a rate, but it's a rate of adding, so to speak. Okay, all right. So it says where G of t is measured in pounds per hour and t is the number of hours after the store opened. All right, so let's read this. It says how many pounds. So if you're going from, if you look up here, these two guys are rates, and this says how many, automatically think integral. If you're going from a rate to how many, always think integral. Now, it also says how many pounds of bananas are removed. So that would be the f of t equation, right? Okay, so I'm going to read it again. How many pounds of bananas are removed from the display table during the first 2 hours the store is open? Okay, so how many, integral, first 2 hours, and it says being removed, right? So we use the f of t equation. And you have a calculator. The rest is a piece of cake. Throw it in your calculator, math 9 that thing, and see what you get. All right, so I have 20.0511 pounds of bananas. Okay, are being removed during the first 2 hours. I'm not writing that down, but are being removed during the first 2 hours. You definitely want to write that. Okay? All right, second part says find f prime of 7. Well, don't you already have this in your y1? Now remember, a calculator is not going to give you the derivative. However, it will give you the derivative evaluated at a certain point, in this case at 7. So since you already have that in your y1, go to your home screen and hit Math 8, which is your n deriv, and type in an x value of 7. And boom, it spits it out. Okay, so that's going to be what? Negative 8.120. Or you could say negative 8.119. Okay, depending on your rounding. They're both acceptable. And then they want to know in context of the problem what that answer really means. So now, because we're dealing with times 7, so I said after the store has been open for 7 hours. Just pay attention before you start writing stuff down. So after the store has been open for 7 hours, I got that from there. Okay, now this is a rate, see, derivative. So that's why I wrote the rate of, and F, remember, stands for the rate of removal. So that's why I wrote rate of removal of the bananas. Then I wrote it's decreasing because we have a negative answer. So decreasing, and because it's a rate, we say at a rate of, and then there's my unit. Okay? Okay, so part C, is the number of pounds of bananas on the display increasing or decreasing? Don't those two words mean that we're looking at a rate? And aren't these two equations here rates? So we're just going to be looking at f of t and g of t. Now I'm going to reread it again. So it says, is the number of pounds of bananas on the display table increasing or decreasing at time 5? Well, wouldn't you really just be taking the amount of bananas that are added? I'm sorry, the rate of adding. I'm so sorry. Okay, because remember G and F are rates. So the rate of adding bananas minus the rate of removing bananas. Okay, so this is the rate of adding. Rate of adding. And this here is the rate of removing, right? Now you have a calculator, so you already have your F equation, I think, in your Y1, right? So just put your G equation in your Y2. And then in your home screen, do G of 5 minus F of 5. Okay, so take a minute, pause me, and get that. All right, so this is what I have here. So if you notice, I have a negative value. So is the number of bananas increasing or decreasing? I would hope you would say that it's decreasing. Okay? And then I would just say something like this. The number of bananas is decreasing on the display table at time 5. Part D asks for how many pounds of bananas are on the display table at time 8. Now, how many? You have two formulas that deal with rates, remember? So if we want to go from a rate to how many, you should think, that means integral. Miss Carter said going from a rate to an amount is always an integral. But also remember in the very beginning, it says when the store opens, there are 50 pounds of bananas. That's like that little boy or that little kid that's getting the head start. So we are starting with 50 pounds of bananas. So the way we're going to set this up is we're going to start with that start amount times 0 of 50, and then we're going to look at the rate of adding minus the rate of removing. However, remember it wants how many. So I'm going to integrate the rate, oops, that was a T, wasn't it? Of adding minus an integral of the rate of removing. Now let's talk about this a little bit more, because remember the rate of adding, if you read the question, it says after the store has been open for 3 hours, they start adding. So that's from time 3 to time 8 in this case, because it says at time 8 there. Okay, whereas f of t, that scenario, the rate of removing rather, starts as soon as that store opens. So this integral is going to go from 0 to 8. So I'm going to say that again. The rate of removing, people walk into the store as soon as they open those doors, that's time 0 to time 8. And the reason why we're using time 8 is because it says it right here at time 8. However, they don't start adding bananas until time 3 because it said after 3 hours. Okay, and don't forget, this is the initial amount of bananas on the display table, so that always has to be there as well. Now the rest is calculator work. You're going to put this in your calculator, and then you're going to put this in your calculator, and just work the whole thing out. Okay, see what you get. Pause me. All right, so you should have 23.347. Now that's pounds of bananas. Okay, I'm going to abbreviate. Pounds of bananas are on the table at time equals 8. Now remember, it's pounds of bananas, not pounds per hour or anything like that, because we're asking for how many.